Welcome to the Explainer. So today, we're going to talk about averages, but not like you remember from math class. We're going to look at averages as a secret weapon, a tool that's going to help you score higher and, way more importantly, save you a ton of precious time on your aptitude tests.
I mean, think about it for a second. You see a problem about averages, and your first instinct might be to just dive into all these long calculations. How many seconds, maybe even minutes, does that take? What if I told you that you could solve them in just a fraction of that time? Well, that's exactly what we're going to unlock today.
So here's our game plan. We're going to start with the absolute basics, the core formula. Then we're going to quickly level up to the shortcuts that really make a difference. After that, we'll get into a pro-level trick for those really messy numbers, and finally, we'll put it all together to crush a tricky test problem.
Okay, let's dive in. Every great strategy has to start with a solid foundation. And for us, that foundation is the core formula for averages. We gotta start here.
At its heart, an average is a really simple idea. It's just that one number that kind of best represents the center of a whole group of numbers. You can almost think of it as the balance point for all your data.
And here it is, the formula we all learned back in school. You just add everything up, and then you divide by how many things you added. This is our starting line.
Let's take a super simple example. A batsman scores 30, 50, and 25. We add them up, we get 105, we divide by the 3 innings, and boom, his average is 35 runs. Simple, right? But here's the thing. Aptitude tests are almost never this simple.
Okay, this is where we start to leave the basics behind. Because the real key to speed isn't just knowing the formula. It's understanding what happens when a new number gets added to the mix. This is where you get that competitive edge.
So, let's look at a classic exam problem. You've got a batsman with a pretty solid average, right? Then he goes out and has a fantastic game. The question is, how does that one great performance change his overall average?
Now on the left, that's the traditional way to solve it. You'd have to calculate the total old runs, add the new score, then divide by the new number of innings. It works, sure, but it's slow, and honestly, it's easy to make a little calculation error under pressure. But on the right, that's the shortcut. Let's break down how it works.
So here's step 1 of the shortcut, and it's super intuitive. We just figure out how many runs he scored above his old average. He scored 70, his average was 36, so he brought a surplus of 34 runs to the table.
And this is the cool part. That surplus of 34 runs, it doesn't just belong to that one inning. To find the new average, we have to spread that bonus out evenly across all 17 innings, including the new one. Everyone gets a piece of the pie.
So what's the actual impact of that surplus on each inning? Well, we take those 34 extra runs and divide them by the 17 total innings. And that tells us that every single inning gets an effective boost of 2 runs.
And that's it. We just add that little increase to the old average. His old average was 36, we add the boost of 2, and we get 38. See that? No huge multiplication, no weird division, just a few simple logical steps. So much faster.
All right, let's level up one more time. This next technique, it feels like a superpower, especially when you're looking at big, ugly numbers and you don't have a calculator. It's called the assumed mean method.
Now this is a special tool for a very specific job. When you see a list of numbers like 99.7, 1002, 99.5, all clustered together, that is your signal. That's your cue to use this trick and save yourself a massive headache.
And the method itself is actually beautiful. First, you just pick an easy round number close to all your values. That's your assumed mean. Then you just figure out how far each number is from your guess. Finally, you calculate the average of those little differences and use it to adjust your initial guess. That's it.
And here's what that looks like in action. Instead of adding all those big numbers, we just pick an easy one as our guess. Let's go with 1,000. Now look at that deviation column. We're just calculating how far each value is from our guess, leaving us with these tiny, simple numbers. -3 plus 2, -5. Adding these up is so much easier. As you can see, the sum of all our deviations is just -10.
So we take that sum, -10, find its average by dividing by the 5 numbers, which gives us -2. And then we just use that to fix our initial guess. 1,000 plus -2 gives us the real average, 998. And we got there without adding a single 4-digit number. Brilliant.
All right, theory is great, but let's put these shortcuts to the test. Let's see how they perform under pressure with a real, tricky exam-style problem that trips up a lot of people.
Now notice, this is basically the reverse of our earlier problem. This time, we know the result. The average went up by 3,
and we have to work backward to find the average itself. This is where a real understanding of the concepts, not just memorizing formulas, really pays off.
Okay, let's break this down. Let's work it backwards. The average went up by 3, right? But not just for one inning. It went up by 3 for all 17 of them. So the total surplus effect on his run count is just 17 times 3, which is 51 runs. Now, where did that 51 run surplus come from? It came from his score of 85. So if we take that surplus away from his score, 85 minus 51, that's 34. And that tells us that 34 must have been his original average before this amazing game.
And now, the final step is the easiest part. We know his old average was 34. The problem tells us it increased by 3, so his new average, after all 17 innings, is simply 37. Done! We just solved a really complex-looking problem with pure logic and some very simple arithmetic.
So what are the big takeaways here? First, the basic formula is just your entry ticket. The real game, the way you get fast, is by understanding how averages shift and change. For those big, scary numbers, the assumed mean trick is your best friend. And really, at the end of the day, these shortcuts aren't just tricks. They're about learning to see the simple logic inside a hard math problem. Look, you've just seriously leveled up your approach to averages. You've seen how to think smarter, not just calculate harder. And that mindset is exactly what you need to crack these competitive exams. So the only question left is, what's next on your hit list?